Hello, this luckiest maths teacher in the world. Thank you so much for watching as we review the mean, median, and mode. So you know that these three things are used in statistics. So what you may not remember is that these are three measures of central tendency. So what I mean by that is that the mean, median, and mode exist to try and give us an indication of where the middle of our data is, where the center is. Actually, it's not just the mean that's the average. The mean, median, and mode are supposed to tell us, on average what the scores were. So sometimes one of them does a better job than the others. So let's have a quick review of what they actually are, how we calculate them. So the mean is the one that most people commonly call the average, even though the mean, median, mode are all like averages of data. So the mean is the sum of all the scores, and you divide by n, which is the number of scores. So mean, just add them all up, divide by how many there are. So the median is the middle score. Sometimes there are actually two middle scores, and you just take the mean of those. So the median is the point in the data where there are the same number of scores above that point as there are below that point. The mode is the easiest to figure out. It's just the most common, or if you like, the observation, the score with the highest frequency. Okay, so let's have a look at some actual calculations. So let's have a look at these numbers here, 1, 2, 3, 4. Okay, so firstly, if we want to calculate the mean, all we do is add them up and then divide by how many there are. In this case, there are 4. So if we add them up and divide by 4, we get 2.5. So the mean of this set of 4 numbers is 2.5. The median is just the middle point. Now, if there are an even number of scores as there are here, then there will be two middle scores. So up here, this and this are the middle scores. We want to find the point here. So we need to find the point halfway between 2 and 3. Most of you probably know that that's also 2.5. If you don't know how to find the point halfway between two numbers, you just add them up and divide by 2. So the median here is also 2.5. Now, when you have a set of scores and none of them are repeated, we say that there is no mode. So this set of data here has no mode. A set of data can also have 2 modes or 3 modes or just 1 mode. It can be bimodal, unimodal, multimodal. Okay, in this case there is no mode, but there isn't always just one answer to the mode. Alright, now we're going to look at what will happen is if I add a data point to this. So I'm going to rub this out. Please pause and copy down if you need. So let's say I have my data 1, 2, 3, 4, and I'm going to add a score that's a long way above. Let's say 160. Okay. So I've now got 5 scores. The number 160 is way, way above all of the other scores. In this case, we say it is an outlier. Okay, an outlier can be one that's a lot larger than all the scores. It can also be a score that's a lot smaller than the rest of them. Okay, so let's look at what happens to the mean, median, and mode. Okay, so firstly, the mean now. Well, we do the same thing. We add them all up and we divide by how many there are. So this time, we're going to divide by 5 because there are 5 scores, okay? So that's 170 divided by 5, which is 34. So the mean of this data is 34. So what I hope we understand is that when I had the data 1, 2, 3, 4, I didn't have the 160 score, the mean was 2.5. So by adding this score of 160, the mean has gone up from 2.5 all the way to 34. So let's look at what's happened to the median. So now there are 5 scores, there's an odd number of scores, the median will be one of the scores, and it's this score here. So the median here is 3. So the median's gone up from 2.5 to 3. When I added this outlier, the median's increased, but only slightly. The mode, well, there is still no mode because no scores are repeated. Okay, so what I'm hoping we understand out of this is the effect of outliers, scores that are a long way above or a long way below the rest of the scores, what effect they have on the mean, median, and mode. So what you can see is this outlier has affected the mean heaps. It's moved the mean up by a lot, but it didn't affect the median that much. And that's because it wouldn't have mattered what number I put there. I would have the same median if this score was 160, or if I cross it out and make the score 5. If I have the numbers 1, 2, 3, 4, 5, the median is still 3. So the mean is a lot more susceptible to outliers than is the median or the mode. And so for that reason, sometimes it's a lot better to report the median or the mode than it is to the mean. So I'll give you an example of this. One example would be in house prices. So what would happen with house prices? You'd have a lot of houses that cost, a similar amount, but then there'll be these mansions that are so big and they cost millions of dollars. They would be outliers, those mansions. And what would happen is they would drag up the mean. So if we talked about the mean house price, it'd be a lot higher than what the average house price is, because it'd be dragged up by houses that have a really, really high cost, whereas the median is less affected. And that's why people don't talk about the mean house price, they talk about the median house price. So we want to use the median when there are outliers. When there are outliers, as there are in this data, the median gives you a much better indication of the center of your data. And if we look back at the data up here, if we had 1, 2, 3, 4, and 160, the mean was 34, so it was here. That's where the mean was. The mean was way more than most of the observations, so it doesn't give us a good indication of the average score of the data, whereas the median was much better indicator. So just bear that in mind, that the mean and the median have different uses. The mean is a great tool. It's a great thing to report on when there aren't big outliers, but when there are outliers, the median does a much better job. All right, the last thing I just need to show you is how to calculate the mean from frequency tables. So let's say we have this frequency table here. So remember, what this means is that this score 7 occurred this many times. So in this set of data represented by this frequency table, the score 7 occurred 5 times, the score 8 occurred 8 times, 9 occurred 6 times, and 10 occurred 11 times. So organising it in the frequency table makes our calculation simple. So what we do is we add another column that is f times x. F is the frequency, x is the score. So we times this number and this number together, and that makes up a new column. So 7 times 5 is 35. The reason that we're doing that is if I want to find the mean of this data here, I have to add up all the scores and divide by how many there are. The problem is that, if 7 occurred 5 times, we don't want to be writing 7 plus 7 plus 7 plus 7 plus 7 on our calculator and then have to write 10 plus 10 plus 10 11 times. We want to do it quicker, and this table allows us to do it. So by timesing 7 by 5, we are adding 7 up 5 times. It's just a lot quicker. So 8 times 8 is 64, of course. 9 times 6 is 54, and 10 times 11 is 110. So the way that you figure out the mean, which we usually put as this over bar x, so it is this symbol here, sigma means sum of, so it's the sum of all the numbers in the fx column divided by the sum of all the numbers in the f column. That's how you calculate the mean from a frequency table. So if I add up all these numbers, I get 263. So that number here is the sum of the fx column, okay? That is the sum of all the scores. We just did it a quicker way. So if I add up all of these numbers in the frequency column, I get 30. So there were 30 scores in total, and the sum of all the scores added up to 63. So the mean is just going to be 263 divided by 30. And that is 8.76 recurring. So that's how you figure out the mean from a frequency table. You make this new column times each score by its frequency, add them all up, then divided by the sum of the frequency column, and that gives you your mean. Alright, hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.